Went out there. Perfect. Can't tell sometimes if we're getting set up slow or we just don't want to talk today, which is fine. I just worry that I start talking to myself and then 20 minutes later, he says, "You can say anything." Doing your best, Julia. All right. Well, that's all one can ask for, right? Don't give up. Stay motivated. Keep working at it. Some days it doesn't feel like you're getting anywhere. And then promise, trust me, keep at that pace. And then once in a while, you get a week and you're like, wow, I did all that? Yep. You did a little bit every day. You'll get there. How's everyone's psychological status? Hanging in there? Is this over yet? Ready to call it? Wishing this was week 2 of the semester. Wishing this was week 15 of the semester. Should we just go home? Let me see me so that you realize that someone is actually here. It's not a Russian bot. Although if I was clever, I'd be teaching this class in what? Beaches of Barbados or something. Maybe Barbados is not warm enough right now, Aruba. Okay, no one's saying anything. So, can you still hear me? Thank you. Okay, so here we go. You voted today. Or if you haven't, you're going to rush after this tutorial and you're going to rush and go vote. Your test is next Tuesday. That is the 17th of November from my usual time slot from 1 to 2:30. You will not get an hour and a half to write the test. The specs for the test will come out later when I finished making it. So, this is your tutorial session. This is your open, what we used to call when I went to school, the recitation. So, typically at this point we'd have problem sets, but this is more or less what can I help you with? What is unclear? Have you found all the assignments? You notice that I gave you a few more lecture minutes this week, and so in exchange I took away an assignment. So you only have one assignment. It's supposed to be a fun assignment. I give you the piece of paper, the PDF, that you can take your own notes on. So, but then I don't want the PDF. I want you to transfer those 10 answers to the Canvas assignment because it's easier for me to grade. Okay? Through the objectives for week 9. Okay. Now, that's going to require that I actually go to week 9, which is doable. And I'm assuming that Professor Cottrell will have some office hours on Thursday. I'll let her announce it, though I won't announce it for her. I'll assume that's what she's doing. Okay, here we go. Ecosystem ecology. Which one are we talking about? Because was it 8 and 9 were crunched together, Pete? So we're talking about ecosystem ecology? Or do you want to go to learning outcomes where it says week 9, climate is a determinant of biodiversity? I thought you should crunch these together into the same module. So just let's make sure we're on the same page before I start pontificating. While Peyton is typing in here, everybody else get your questions out and your notes out. So the climate one. So it says at the top, week 9, climate is one determinant of biodiversity. And we see some dead trees there. Okay. Well, it's since I wrote these, I guess I should know what we're talking about, right? We will see. Is there a specific one, or should I go down the list? I don't want to waste your time if there's only two of them that you wish to go down the list. So we're on the same page. So define climate, identify the extrinsic and intrinsic factors that contribute to the diversity of major climatic zones on Earth. All right, so define climate. We should be able to distinguish between climate and weather. Okay? So weather we understand is the day-to-day, week-to-week, month-to-month variation in those parameters that we typically measure when we think of weather. Temperature, humidity, barometric pressure, wind speed, wind direction. You got it? That should be straightforward. Climate is the long-term averages of those weather parameters. Okay? So if we're talking about today, it's going to be, I'm looking out the window, 62 degrees and sunny. That's the weather today. If we say that over the past 100 years, the average temperature in November in mid-Michigan is 62 degrees, that's going to be climate. Okay, we okay with that? So I'm just going to keep going, and then I'll occasionally go pause, yes, yes, and then you can respond. Extrinsic and intrinsic factors. So there's a, if I remember correctly, there's a slide. There's two categories. The extrinsic factors are factors that occur, think about it as external to Earth. So the shape of the Earth's orbit around the sun, the tilt or the angle of the tilt of the Earth on the longitudinal axis that runs through the North and South Pole. Looks like I'm looking away, but I'm looking at this side of the screen, and then I have to look back over here to look at the chat box. Okay. We have the wobble of the Earth as it rotates. The rotation of the Earth itself contributes to the Coriolis effect. Okay, so extrinsic factors. Intrinsic factors. Let's see, things like the composition of atmospheric air. So that's euphemism for what are the concentrations of the molecules in air. Okay, so those are intrinsic factors. We could even say intrinsic factors on a regional or smaller scale would be the topographic regime. Is this a flat plain? What is the, or are there mountain ranges nearby? The altitude, okay, would have an effect. The latitude would have an effect. Okay? So those would be kind of intrinsic factors. All right, so that's number one on my list. So is that, someone give me a thumbs up or thumbs down? Okay, now, is that one more, is that too much detail, not enough detail, or Goldilocks just right? Okay, so I'll assume that's okay until you step in and tell me something else. Okay? So I think the dog is going to wrestle behind me. My kids don't have school today. So describe the greenhouse effect and its importance. So the greenhouse effect is the phenomena that retains heat on Earth. That's what the effect is. It retains heat. What is the source of the heat? Solar radiation from the sun. Okay? What is the now listen to the terminology. What is the mechanism by which heat is retained? Molecules in the air reflect solar radiation back down to the Earth and do not let it escape back into space. Okay? Now, what are the molecules of that mechanism? Carbon dioxide, nitrous oxide, water vapor, and methane. Okay? Its importance is, without the greenhouse effect, we would not have life on Earth. There would, right? As we know it. So it retains heat. Now, you got that? That's just the mechanics of the greenhouse effect. So you have to know what the effect is, what the consequence of the effect is, retention of heat. You have to know the mechanism of how it works. Heat is reflected back down toward the Earth. Why is it reflected? Because of these molecules in the air. Okay? Now, end of sentence, period, space, space. It is neither good nor bad. It just is. Okay? I mean, it's good in the sense that it allows life on Earth as we know it. Okay? If there was no greenhouse effect, I would argue that there would not be enough heat to have what we have today, or what we think we have today when we look around the Earth and the life on it. The greenhouse effect is a blanket. You want to magnify the effect, you add more blankets. How do you add more blankets? You change the composition of molecules in the air. Okay? So when we talk about greenhouse effect, and we talk about climate change, what we're really saying is the magnitude of the greenhouse effect is going to change and result in climate differences. And why is that going to happen? You have to know the mechanism, which is we've altered the composition of molecules in the air. Okay, so that's the connection. You have to know the concept of greenhouse effect to understand how that's related to changing climates. Okay? Moving on to number 3, relate how heat moves. Yes, it's important because the greenhouse effect retains heat, and the heat is derived from solar radiation, the sun. Okay, so the sun is the planetary body, and the sun emits solar radiation, light and heat. Okay, how does heat move on our planet via global wind patterns and currents? So heat, when it hits Earth, doesn't just stay there. Heat moves. Wind currents move heat. Hot air rises, cold air sinks. When hot air rises, it moves away from the equator. It cools off eventually, and then cold air sinks. As it sinks, it warms up. And at some point, it moves along the surface of the Earth, and then it gets cool, and then it rises again. Okay? So that's one way that the wind can move heat across the surface of the Earth. The solar radiation is also absorbed by water. Water is not static. Okay? Water moves. Just as there are wind currents, there are water currents, there are ocean currents. There are currents in Saginaw Bay. Right? We just don't talk about it. There's a tide in Saginaw Bay, actually. We just don't talk about it because the tide is very small relative to going to Florida and seeing the tide, high tide, low tide differences. That's not the point. The currents of the waters they move carry heat with them. Where did the heat come from? The heat came from solar radiation. So, you go to the East Coast, the eastern seaboard. There is the Gulf Stream, which flows from the Caribbean up across the eastern seaboard of the U.S. And then once it hits about Massachusetts, it starts deviating and bends out toward the mid-upper Atlantic and heads toward Iceland and Scandinavia. It's carrying heat from the Caribbean with it. That's why the hurricanes, in part, follow those particular paths. They're following the heat of water up through Gulf of Mexico and up the eastern seaboard of the U.S. Okay? Hurricanes like heat. So, if you want more details, there is a slide that shows you what are called the cells. So, the meteorologists call cells of air that circulate, right? Circulate heat. And that's what your book referred to as the Hadley cell, the cell that's closest to the equator, where the hot air rises, and then it moves away from the equator, and then as it moves away from the equator, eventually it cools and it sinks back down, then it warms up, and it travels, still continues to travel, and then as it heats up, it moves out and around again. Right, so those are cells. That's as detailed as we're going to go with respect to air circulation patterns. And right now, that's as deep as we're going to go with respect to ocean current patterns. I'm not going to ask you to memorize the ocean currents. But in North America, you should know that the eastern seaboard, there is the Gulf Stream. Not to be confused with the air pattern that's also called the Gulf Stream that moves from west to east, that brings all our weather, or much of our weather patterns from the western U.S. and western Canada. Okay? The difference in tides, ocean versus Saginaw Bay, does have to do with the size of the body of the water. In part, it has to do with the size, the volume of water. That's what I'll go with. Okay? I think, Jessica, that in lakes, the tide is called niche. Have to look that up and double check it. It's been a long time since I've studied limnology. But the tide could be a couple inches. You're just not going to notice it. Okay? We're probably more susceptible to big wind patterns and wind changes that would drive water up higher on shore. That's going to be more noticeable than a tidal shift. And of course, the strength of the tide has to do with the location of the sun and the earth and the moon, because they're all gravitational forces pulling. That's why you have what is called a neap tide, a low tide, and a high tide. Okay, moving on. We okay so far? I see people typing. You're not interrupting. Yes, week 10 is on Tuesday's test. So chapter 46, chapter 47, chapter 48. That is correct. Okay? So I gotta look at my calendar. When was your last test? Your last test did not cover ecosystems, right? So I would say it's gonna be ecosystems. It's week 9, which is climate derivatives, and then week 10 is messing with the system. Make sense? Are we kind of in agreement with that? About, I think your last test ended at the community level, community college. Okay. Keep asking Cassidy if it's not clear. All right. So predict how various topographical features affect the climate. So this is the idea of a big mountain range. So this is the concept of what is called the windward and the leeward side of a mountain range. So the wind hits the windward side. The wind is driven up the mountain range. As it's driven up, what happens? It loses heat. Which type of air holds more water? Hot air or warm air? Hot air. So therefore, the water has to come out of the atmosphere as the temperature drops. That's just how it works. Okay? This is, again, why you get more thunderstorms in the summer than you do in the winter. There's just more energy in hot air at higher temperatures. So it's driven up the mountains, right? And we're talking about like big mountains typically. We're talking about the Canadian Rockies. We're talking about the Appalachians. We're not talking about the 3 hills that you went over to grandma's house, okay? Particularly in this part of the United States. This is all flattened from glaciers. It's almost as flat as you get. I mean, it gets flatter, but as you get closer to Ohio and Indiana, it's like nothing, right? The curve has more change in elevation. So I get excited. This is cool stuff. So cool air drops the precipitation. It comes down the backside. As it comes down the backside, that's called the leeward side. It warms up as it drops. It starts to pick up more moisture. It just starts to absorb more moisture because the temperature is increasing. And typically, on the backside, on the leeward side of a mountain range, it is much drier. So drier is called arid. If it's really, 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 really dry, it's called xeric. Since we're learning terminology. And so that is an example of how a topographical feature can affect climate. Now remember, that's day to day and month to month and season to season, but that's also going to have long-term consequences. Okay? So all of these mountain ranges were not here forever. The Andes are relatively new in South America. So every time the mountain range changes or appears, that changes that you should expect that's going to change some regional climate. Okay? And of course, think about the Himalayas. The Himalaya mountains only appeared because the subcontinent of India crashed into Europe, and when it did, it pushed all the, how do you like that? It pushed up all the mantle and the crust to form the Himalayas. It's just driven into the southern end of Asia, plate. Okay? Describe what factors give rise to specific types of biomes. So here's what you do for the next 3. Identify and describe the different terrestrial and aquatic biomes, list the characteristics of each. So number 1, what is a biome? That's what you have to be able to define. What is a biome? And recognize the definition. So it's this large geographical area. What the hell is large? I don't know. There's no exact definition of large, okay? But it's bigger than this city, it's bigger than the county, and it's bigger than Michigan. It's large, okay? So it's this large geographical area that shares a common set of climatic conditions, whatever those are. Okay? Now here's how it bleeds into terrestrial and aquatic biomes and the characteristics of each. So it shares a set of common climatic conditions. Because it shares a set of common climatic condition, it shares a particular flora. Okay? It shares a particular flora. Flora is the easy way to refer to all the primary producers. Okay, so it's the plants and the trees. Fauna is in reference to animals. But we can write a book called The Flora of Michigan. Okay? And that's not a synonym. So it turns out then that with respect to terrestrial biomes, those biomes are often defined by the flora. Okay? So the way that you recognize what biome you're in when you're looking at a terrestrial biome is you look at the plants that grow there, and then you make deductions. Well, I don't see any plant that's over 3.5 feet tall. Therefore, it's right. Therefore, it's not a forest. So it can't be a temperate forest. It can't be a tropical rainforest. It has to be somewhere where tall plants and trees do not grow. And so you just work your way through deduction to figure out what that is. If you only see a piece here and a piece there, and it's scrub amongst sediment, sand, then that's a different type of terrestrial biome. So the biome is this large chunk of geographical space that shares that area shares common climatic conditions. The common climatic conditions have selected for a common flora. You recognize terrestrial biomes by looking at the plants. Okay? Typically, that's how it's primary producers. Okay? Aquatic biomes, a little different. It's when we look at something, we look at Lake Huron and we look at the ocean and go like, I don't see any trees. I don't see any plants. So the conditions, how the characteristics of the traits that you use to recognize them are a little different. So you use a little more flora, you use a little more fauna than you did in the terrestrial biome, and you look at like just the space available. It sounds stupid, but I don't have an exact way to describe it. You recognize a coral reef when you look at it, right? How do you know it's a coral reef when you look at it? You see coral. You see that structure. You see that three-dimensional structure. You expect to see a particular distance. If you're in the open ocean and you're in underwater, you expect to be able to see further. You don't expect to see coral. You don't expect to see the bottom. You see where I'm going with this, Peyton and Kayla and Madison? Like you're doing this without recognizing perhaps what you're doing. Now, if you stop and think about it, that's true and it's good. Victoria, you got to stop and detail out, what the hell am I actually noticing in this? So that's the important things I need to recognize. Okay, but you're doing this on Gestalt already. Okay? So those 3 points, describe the factors that give rise to species. Those are the climatic conditions. Okay? Typically, it's going to be temperature and water. Why? What are the 3 and nutrients? Because those are the 3 things that primary producers need. So if the terrestrial biomes are based on the flora, then you know that primary production relies on temperature, solar radiation, the amount of solar radiation, let's do that, water availability, and nutrient availability, and those are the criteria that define the biome. Okay? And so then all you have to be able to do is differentiate between terrestrial and aquatic biomes based on that flora, based on those primary producers and what you see. So if you give us a diagram and ask us to differentiate biomes, we group them by similar flora and fauna. Yes, that's one way. So if I gave you a bunch of pictures and I said, match the picture to the biome, here's what would go through my head. You ready? First of all, I look at a picture. I go, is that water or is that land? I mean, that's occurring in your head without you even realizing it. That's what's going to happen first. All right. So let's assume it's land. So therefore, I get rid of all the aquatic biomes in my head, right? By elimination. Now I look at it and I go, do I see trees? Yes or no? No, I do not see trees. Okay. Now I get rid of all the rainforests and different types of coniferous forests, deciduous forests, etc. They're gone. So what do I have left? Do I see a bunch of grasses? Yes. Okay. Grass everywhere? More or less. Okay, so I'll call that a grass, or a savanna, or a steppe, or how exotic do you want to make it? Yeah? So that's how I would do it. If I didn't see trees and I didn't see grasses, then I just keep working my way down. Do I see scrub bits here and there with a lot of sand and rock and sediment between it? Or is it a solid, consistent layer that looks like carpet? If it's a solid, consistent layer that looks like carpet, I'm going to call that tundra. It's going to be moss and peat, etc., lichen that are there. If I see a lot of sand and sediment and rocks, and then I see scrubs here and there, I'm going to say, maybe that's desert. That's consistent with the desert biome. Okay? And so what I'm doing is just, I'm recognizing the flora, and in my head, I'm understanding that, like, well, the reason I don't have trees might be the lack of water. The reason I see that much sand and rock could be the lack of water. The reason I don't see tall trees could be the temperature regime. Okay? So that's what I mean when I say identify and describe terrestrial biomes and aquatic biomes. List the characteristics that are important in defining aquatic biomes. So primary production on terrestrial systems, we've said the amount of water, the amount of nutrients, the amount of solar radiation. Okay? Aquatic biomes will be similar when you look at that. I would look at the aquatic biome and look and see how much space do I see? Do I see the substrate, or does it all look like open bathtub? Okay. Do I see structures on the substrate if there's there? Does it look like coral? Does it look like kelp? This kelp is a different biome than it is in coral. Does it look like I'm close to shore? Does it look like I'm offshore? Aquatic biomes, I think terrestrial biomes are intuitively easier to identify and do it without thinking, because probably we see more of them. And the names associated with any aquatic biomes overlap with each other. There's a lot of synonyms. And in one of those lectures I talked about, it really depends what your criteria is for dividing the biome. So for me, the important things that you recognize now is that if you look at vertically, if you look at your bathtub vertically, okay, there's a layer at the top where the light penetrates, and then there's a layer underneath that where there's no light. So that's the photic zone, and then the aphotic zone. And I realize your bathtub is going to go to the bottom, but you get the idea. Just expand it out. Think about Lake Huron. Okay? So vertical striation of the water column is photic zone and aphotic zone. Now, why is that important? Because primary producers need light. And so primary production is only going to occur in the photic zone. Someone asked last week about the importance of upwellings. Well, this is why upwellings are important, because they're down here, currents that are aphotic, they hit the continental crust, the continental slope, that are driven up into the photic zone, and now you have nutrients with light. Now you have primary production. And typically it makes that noise when you hear primary production. Okay? So a latitudinal differentiation of the aquatic habitat is near shore, away from shore. Okay? So it's not like you look at it and go, oh yeah, I see trees, no trees, I see grass, no grass, whatever. It's near shore, far, distant from shore. They get different names. So they call it, what is your book called? Oceanic zone versus neritic zone. I just say coastal, because it's along the coast, coastline. Doesn't matter if it's freshwater or saltwater, it's still a coastline. Okay? So, and then you can look at one, if you wanted to, you could look about how much stuff, how open is the space that you're in. If it's vast open swaths and you can see forever, I call it pelagic zone. Right? That's open ocean. Otherwise, you're in some kind of coastal area, and it gets 6 different names depending on subsets. I'm not going to be hyper fixated on that. Okay? So let me pause. If we're looking at learning outcomes by my ramblings here. I think we're down to, I think we've discussed the biomes, traits of terrestrial versus aquatic biomes, the characteristics of some of the aquatic biomes. And now we're on describe climate and nutrient availability. Is that, if everyone wants to look at that page and those learning outcomes, I think that's where we're about. I'll pause here. Give you a chance to breathe, your pencils a chance to recover. What do you think? I'm going to wait for someone or two people to respond and tell me we're okay or ask a question. Okay. Thank you, Madison. Somebody else is typing, so give it a chance for the... All right, Jessica, good. Okay, that's all right. Good, good. I hope we're making some progress. All right. So, how does climate and nutrient availability impact patterns of primary production? So, big question. We could answer it in 16 volumes. Okay? Nutrient availability. What are the nutrients that we're talking about? So here I'm going to ask for some typing. What are the nutrients that we need with respect to primary producers? Type away. Okay. I like Madison's answer. I'm going to go with nitrogen and phosphorus as nutrients. And Peyton, I think that most people would assume that when you say nutrients that you're talking about nitrogen and phosphorus per se. Okay, it is true though, as you've identified that you need light and solar radiation and you need water in photosynthesis. And obviously you need carbon dioxide. But I would hazard a guess that when it comes test time and someone's referring to a nutrient, they're referring to nitrogen and or phosphorus or some other element. Okay? So you would still need the substrates of carbon dioxide and water. Definitely. All right. So nutrient availability is going to impact primary production because you need all three of those elements. You need nutrients, you need light, and you need water. If you're absent one, that is going to limit the amount of primary production. So let's go back to our terrestrial biomes. Why are there often so few plants in the desert biome? Because it's the lack of water. Solar radiation? Oh, they got plenty of solar radiation. That's not the problem. The problem is the lack of water. So it's the lack of water that limits primary production. Let's go back to the oceans along the coastline. That photic zone, near shore, in the coastal area. Light? Oh yeah, there's lots of light. We're in the photic zone. Carbon dioxide? Yeah, well, it's dissolved into the ocean. What's missing? Nutrients. Nitrogen and phosphorus. We know that that's missing because when there are upwellings that bring nitrogen phosphate, we have these big blooms of primary producers. Okay? And I would hazard a guess that if you're on Jeopardy and the topic is primary production, and the question is, what is the most frequent limiting element to primary production? Your answer is going to say, what are nutrients? Okay? Typically, it's nitrogen and phosphorus which limit primary production. Now, what is my evidence for this? Now, we're jumping ahead, but what is my evidence for that? My evidence for that is when you add nitrogen and phosphorus in the form of fertilizer to land, plants grow faster. So, must have been enough water there already, and there must have been enough sunlight there already. You just added more nutrients. What is my evidence for this? When you go to the Great Lakes, and in the summertime, when the rain hits the land and across the fields and carries with it the fertilizer into the lake and the rivers, what happens? You get massive algae blooms. Why? There was already plenty of water. It's the lake. There was already plenty of sunlight. You added fertilizer, and so you got additional primary production. So That's going to be my argument with Alex on Jeopardy. Okay. Now, how does climate impact primary production? Because remember, one of the elements of climate is going to be solar radiation. Okay. So we're mixing the two ideas here, climate and or temperature. These long-term trends in combination with nutrient availability is going to help define patterns of primary production. Lots of primary production, a little bit of primary production. Seasonal patterns of primary production, or a more consistent output of primary production. Okay? Pause. I'll wait for a response while I read the list. Doesn't always have to be Peyton. Schwartz, how you doing? Okay, still good. Good. Good that it's still good. You know what I mean? Good. Okay. It's late in the semester, eh? Tired. I'm tired of being tired. Relative rates of primary production in terrestrial environments to water. I have no idea what that sentence even means, and I wrote it. Describe how climate and nutrient availability impact patterns of primary production, the relative rates of primary production in terrestrial environments. I wonder if I meant in relative to water and nutrient availability. I don't remember what I meant by that, so I'll just go back and delete it. But it's probably a continuation of the discussion that we just had. How much primary productivity occurs in different environments based on water and nutrient availability. But I'm just going to delete it. So honestly, what did I mean? Relative rates. Okay, so I think by that statement, I'm trying to get you to the idea of what is the limiting reagent. So those of you in chemistry, remember those equations, and you figure out how far can the equation go using substrates to get your products. And typically, there's always one substrate that is the limiting reagent. That's when you got to calculate the moles and all that other stuff to figure out who's the limiting reagent that drives the reaction. I think that's what that point is getting to. Identify the limiting reagent, and that was the principle. Does anybody remember the formal name of the principle? About that there will only be so much primary production based on the limiting reagent, whatever that is. In some cases, it'll be water, desert. In some cases, it'll be nutrients. In some cases, it might be light. Anybody remember what that's called? What that formal name was called in your textbook? It followed the pages just after all the biome pictures, I think. Someone look it up and see if you can find it. I think it begins with L. Make a note to edit at that point. Anybody gonna look for it? All right, Leah and Emily, I'm gonna task you with going to find it. We're looking for the formal name of the principle, which describes the phenomena that primary production is going to be limited based on whatever of those three factors is not available or the least available. It's going to be in your text pages somewhere about following the biome pictures while we go on. This is what I would do in the class anyway, if we were in person. Yes. So Liebig's law of the minimum, all right? So the Liebig's law of the minimum is the fancy name for the statement that recognizes the phenomena that primary production will be limited based on whichever is least available. Water, solar radiation, nutrients. Intuitively, to me, you should understand the principle, and you're just applying a fancy name to it. Who really cares? You change the name, but that doesn't change the principle. Understand the principle first, because then you can apply it. You can't apply Liebig's law of the minimum, right? If you don't know what that is, it doesn't matter what you call it. Okay. That's the one I messed up. Okay, so here we are. Describe the key factors limiting primary production in aquatic environments. So we've been hinting at that. typically it's not water. Okay? And if it's in the photic zone, it's not light, largely, roughly speaking. So in many cases, it's going to be nutrient availability. Again, we can go back to our what is my evidence to support that statement. When rainfall runs off land, carrying fertilizer with it, I get algal blooms, right? And upwellings around the ocean that bring nutrients to the surface into the photic zone, I get algal blooms. I get bursts of primary production. That's going to be my evidence for the statement. Predict changing patterns of species diversity along a latitudinal gradient. So this is actually a reflection of what you did. I think there are a couple of questions about this on your last test, right? The species diversity tends to decrease as the latitude increases. There's this inverse relationship. So latitude, of course, is starting at 0 at the equator, 90 degrees at either pole. So as that number increases, the number of species or the biodiversity tends to decrease. General pattern. Okay, now we can argue something more interesting. Why? Why is that the general pattern? And let's stick only to land for now. Okay? Why is that the general pattern? I mean, the easy one right off the bat is biodiversity is related to primary production. There's typically less light available as you move from equator to pole. So that could be a factor. Not just straightforward, right? Putting the pieces together. We would assume that carbon dioxide levels are more or less constant around the globe. That's going to be a general assumption that we'll just make. True everywhere? Probably not, but we're going to make the assumption. Otherwise, it gets ridiculously difficult to figure out anything. All right. Explain the contribution of environmental change and natural selection in forming Earth's biome. All right. So now we got to go back. All right. So what is a biome? It's this large geographical area that has a shared climate and therefore typically a shared traits and species of primary producers. Okay. How does natural selection help form or develop that community of primary producers? Well, this goes back to section 1 of the course, right? It's going to select, if the Liebig's law of the minimum says that water is going to limit primary production, then it's going to select for plants that can either grow in low water conditions or plants that retain water. The cactus retains water. The jade plant that you might have in the window of your house retains water. That big fleshy leaf is full of water. So it retains water. So when I talk about how does natural selection assist in forming biomes, well, just put the pieces together. Right? Biome, big geographical area, has a common primary production output, but also probably similar species, similar communities. Maybe that's a better phrase. We know that selection is a force that limits variation or drives adaptation to a particular area as being, what are the limiting elements in this which are causing selection to occur? The amount of light, the amount of water, the amount of nutrients. And so the plants that you get because of these 3 selection factors, right, have to live in those climatic regimes. You have to live under those conditions. So really that statement is just piecing together what you already know, but getting you to recognize that the process here, the phenomena here is selection. Okay? Explain the content and environmental change. Well, that's what we're going to come to next in the following week. But it's the same thing. Because what does environmental change do? I'll wait for an answer on this. What does environmental change do with respect to selection forces? What's the relationship between those 2 things? Selection and environmental change. How do you make the mental leap between those 2 ideas? You're going to type for me. Come on, ladies. And Mr. Mason, don't leave everything up to Peyton. What's the connection? How do you connect the ideas of changing environment and selection? As the climate changes, natural selection will start to go towards traits that fit the new environmental climate. Sorry. Yep. Okay. Someone else is typing. We'll see what they've got. I don't understand how the chat box works. Your name shows up typing, and then it disappears, and it comes back, and it disappears, and then magic message appears. Yeah. The species will have to evolve to survive in the new environment, right? So we have selection forces. Selection forces are always present, always. Okay? A change in environment means that you perhaps change the temperature, that perhaps you change the rainfall pattern. And the rainfall pattern could not only be how much it rains, the volume of the rains, but when it rains. It's very important as to when it rains as opposed to how much it rains, right? Ask a farmer. If you change when it rains, the amount of sunlight or the amount of nutrients, and we've indicated, or we know that those are already selection pressures in the population. This is my population of plants. And the population now has under a different set of selection pressures. If the intensity of the selection pressures change, or the type of selection pressure changes, in the population, I'm going to use population instead of species here, Jessica, and the population will respond to those new selection pressures, okay? And this is exactly when, and now, I mean, we can jump all the way, what is this week, week 10? I have no clue. You could jump all the way to the last lecture I posted for this week about climate change and the effect on populations. Okay? So, let me type what we just stated in part so it's clear. The population is already under various selection pressures. Okay? The primary producers, and we know, according to Cassidy's Liebig law of the minimum, let's just pick one. And let's go nutrients. Okay, we're just making an example. The nutrients is the limiting reagent to the amount of primary production. Okay? And so, in response, I can't type when people are watching. The community plants appears at and adequately deal with those selection pressures. Okay? Now, climate change or environmental change occurs. Rainfall. So now we're gonna talk about rainfall patterns. It rains only in April and May, not in June or July anymore. Okay? Well, that changes the selection pressure. Selection pressure changes. Now the limiting reagent is not nutrients, because what limits primary production is now when rain falls. Okay? So in response then, a new plant, I can't spell plant, new plant community appears with the species that can withstand the change in selection pressures. Okay? And so that's how I would build the story. And let me just make sure we're on the same page. Change of selection pressure could be the pressure changes from X to Y, or the intensity of pressure X changes. And either one, the population has to respond, right? Makes sense. If the pressure changes, in this case, in our little example, from nutrients, which is the LR, to to rainwater, which is now the LR, and that's an entirely different selection pressure, okay? Or the priority has changed. Let me put it that way. We're both there currently. The intensity of pressure can also change. So let's say that there's a big volcanic eruption, uses ash, which blocks solar radiation. Now, sunlight is 1/3 of what it used to be. And now that is going to greatly affect primary convection. So now the intensity of the pressure has changed. The pressure was solar radiation. You conduct photosynthesis, and now there's less. So if you're a plant that requires high light levels, you now have a problem, right? And so, as Jessica points out, the traits in the population which are favored change every time selection pressures change. What was good today may not be good tomorrow if the selection pressures change. And this is ultimately where we're going in this week's lectures of this is what's going to happen as climate continues to change. That's a euphemism to say the selection pressures are changing. So populations have to respond. And in the lectures, we talk about three different responses. Okay? They can die if they can't respond. If they can disperse, that is, get away and find a better microhabitat, they could do that. Or the population is going to shrink in size like a bottleneck. All right? So, Peyton, according to my mental checklist here, I think we plowed through most of those learning outcomes on week 9. Everybody want to have a look-see and see if we're okay? Or if you got another question about those learning outcomes or something that we just mentioned. Nice typing, so I'm just waiting. That's what I'm doing. Everybody else, flip through your notes. Make sure we're on the same page. What other questions do you have? Jessica, I don't remember seeing you on Monday, but in the event I missed you, you might have a group that's trying to find you in 111A lab. 181 lab, just FYI. Some of you have suffered with me with your lab, right, Leah? That's no worries. Well, that's fine. Just don't want it to slip by. Yes? Yes. So, when we talk about topographical features, we're talking about surface features, okay? Surface features. Like in mathematics, there's a particular discipline of mathematics called topography, where you study the surface of solutions. Am I going off the deep end? Okay. We're talking about surface features of Earth. So that's probably a category of geography. Okay. Surface features affect where rain can fall. Okay, we'll start with rain. Surface features can affect rain. Let me say rain patterns. Or let me back up. Surface features affect precipitation patterns. Okay, that would be all encompassing. This has to do with the idea that really high mountain ranges, for example, force air to go up and over them. The air is not going through them. The air has to go up and over. When air changes altitude, it changes temperature, and vice versa. When the air changes temperature, it changes altitude. All right. If it's being driven up a mountain, it's going to get colder. There's nothing, that's it. That's physics. That's not biology. That's physics. Okay? As it goes up, it changes in altitude, it's going to get colder. Cold air holds less moisture than warm air. Again, that's physics. That has nothing to do with biology per se. Okay? Cold air holds less moisture. So if the air temperature changes and gets colder, it can therefore, by definition, hold less water. It has to get rid of the water. It's going to get rid of it by peeing on the land, right? So it's either going to be rain or snow or sleet or hail, but it doesn't matter, right? You get the idea. And so it has to drop all of that moisture as it gets colder. Okay, let's say in this case it gets over the mountain range. It's going to start to descend. Why? Because cold air sinks. Cold air is more dense than warm air, right? So because cold air is more dense, it's going to sink. That's physics, density. So as it sinks, it warms up. As it warms up, it sucks more moisture out of everything. Plants, soil, air. It just sucks and sucks more air up, more water up that's available. And when it does that, it pulls water out of the ground. It pulls water off of the trees, right, or whatever plants are there. And so you typically end up with a drier habitat on the what is called the leeward side of a mountain range. Okay, the leeward side. That's where it's dry, right? That's where it's more arid. Okay, and so just the fact that that mountain range is there is going to change rainfall patterns. Right? If the mountains are there for 10 million years or 6 million years, that is climate. It is affecting rainfall patterns. This is why you will always find the tropical rainforests in North America on the western side of the big mountain ranges in northwestern US and Canada. Because the water and the weather, the winds come off the Pacific Ocean, hit the mountains, drive up. As they do, it rains here all day long. So the rainforests are here, drives up. And then down this side, it's just open space. These are the prairies on this side. These are the Great Prairies. Right? These are the vast fields. There's trees, yes, but there's not forests of trees. It's grasslands everywhere. Okay? Because one, it's more arid. There's just a lack of water. Okay? So that's a very specific example of a topographical feature. There are other examples that we could produce. Clusters of volcanoes, right? The topographical features that could form something like a mountain range. Vast open expanses allow winds to blow harder because there's nothing to stop and slow them down. Right? That wind speed and wind direction is going to produce some kind of selective force on what can live there. Okay? If you turn this, that'll get, never mind what I was going to say next. So think about topography as surface features of the earth that can affect weather. I mean, arguably, could we argue this? I guess if we really wanted to argue that big canyons, big divots in the ground can also affect climate because cold air sinks and cold air is going to float down in through canyons. And that's going to affect light levels because of the walls of the canyon. So, I mean, arguably, depending on how far you want to take it, big canyons like the Grand Canyon and such will affect small scale, what I call regional climate patterns. Okay? So maybe that's the hint here. Maybe that's the clue. The topographical features I consider on a regional geographical scale. Okay, so why? Because the rainforests are in a very limited geographical space. The prairies stop by the time we get closer to the Great Lakes, so the effect doesn't last forever. Like the leeward effect, what is called the rain shadow. Rain shadow on the leeward side doesn't last forever, right? It doesn't last until the end of the continent, for example, at least with respect to North America. And that's that. Better, worse. Just remember, if you're stuck on the word, I'm not sure how you're thinking. If you're stuck on the word climate in that statement, just start with weather. How does a mountain range affect the weather? And then all I have to do is multiply that times 1,000,000 years, and now I got climate. Or it doesn't have to be 1,000,000 years, right? You could do it over a couple centuries. And maybe that's, yeah. Maybe that's easier to understand the weather first, and then you just multiply that out to get the climate. You're in the same place. Okay. Peyton's asking lots of questions, which is good. The others of you. It's Anna, Daniel, Sheldon, Schwartz. Are there questions out there? If you don't, that's fine. I'm just making sure you got an opportunity to ask. Johnson? See a bunch of people typing, so give them a chance here. Yeah, I can do that. Let's see what everybody else is typing in. I'm just doing all this with my hand motions. If we were in class, I'd be writing on the board. Do not apologize for questions. Right? I get paid by the question. It's no big deal. It is what it is. You ask questions because you know somebody else out there has the same question. All right, Madison? So works for you as well. All right, yes. So Kayla asked an upwelling. So in our context of discussion so far, Kayla, the upwelling is in reference to an aquatic habitat. So that's the first thing. Okay, so when you hear that, I want you to think water. Typically, when we're talking about upwellings, it's often in a marine setting. Does it have to be a marine setting? It does not have to be a marine setting. It's a concept, but typically in your book, they bring it up when you talk about marine habitats. Okay? An upwelling is exactly what it sounds like, up and well. Water. If you think of a well, what happens in a well? You put a hole in the ground, water goes to the hole and comes up the hole. Okay? So the upwelling is exactly that. It's a movement of water up. How far up is up? I have no clue. There's no definition that says the water has to move this far up to be an upwelling. Okay? I would hazard a guess that when someone's talking about an upwelling, particularly in the marine environment, they're talking about potentially hundreds of feet of movement with water in a vertical plane. Okay? In a vertical plane. So you don't understand what I mean by the difference between where it was and where it's going is at least 100 feet or more. Right? In many cases, thousands of feet. Okay, so now that's physically what it is. Water is moving from a lower level, okay, and in this case, strata are layers of water, just like strata are layers of rock. So you have different strata of water, and the upwelling is just taking something near the bottom or at the bottom and putting it up at the top. Now, why would it go that way? Well, first of all, let's go back to the observation that physics says that much like cold air sinks, right, cold water sinks, because cold water is denser than warm water. You know this if you've ever been swimming in a pool or the lake. The further down you go, it's like, ooh, it's getting colder. Why? Cold water sinks. Okay? So the cold water at the bottom then has a tendency to not rise. It wouldn't unless it's being forced to rise. Because physics said it's denser. And we know that denser things sink. So there's no reason for this cold water to move. Because something has to make it move. So what is going to make it move? Well, what we don't see when we look at Huron, yes, we see wind across the top, and we see some waves, and we might even see a current if we throw a stick in and watch it move down. But there are also layers, there are also currents underneath the surface. And the same thing is true in the ocean. And this is the confusing part, but the really cool part is that the currents often go in different directions. Sometimes the surface water goes this way, and sometimes the water near the substrate near the bottom goes that way. And they can go in different directions. And so when you Google a picture that says ocean currents, you have to pay attention. Is this surface current or is this at depth current? Okay, because they can go in different directions. But right now we're going to talk about at depth currents. And we're not going to talk about the surface currents. We're going to talk about at depth currents. So this is the really cold water at the bottom of the ocean or lake, and it's going in a particular direction. And there's no reason that it's going to go, well, you know what, I'm kind of bored of this shit. Let's go this way. It's only going to go up if it's forced to go up. And why would it go up? It would go up if it hits some kind of underwater wall. Now, water has to go somewhere. So it could go down, it could go left, and it could go right, but some of it's going to be driven up. Now, instead of a wall, right, North America doesn't end. So here's the land of North America. It doesn't end like that, like a swimming pool, and there's the ocean. Okay? What you don't see is that this is the crust of North America, and then there is a slope, like getting into a kiddie pool. So the slope looks like this. Okay, so here you're living up here. There's the house. Okay, and then you go to the edge of the water. You go to the edge of the land. You jump in the water. And it doesn't go straight down, but the land slopes. This is called the continental shelf. It is a real name. This is where all the coral reefs are. This is where most of the life is on the continental shelf. Why? Because there's a substrate, and typically most of this is in the photic zone. So this is where most of the primary production is. Okay, so the water now down is back here, and it's flowing along. Instead of hitting a vertical wall, it hits a ramp. So it just says, "Why, this is easy. Hit the ramp, and it's driven up." So here's my land, there's my house. Okay, so as the water is driven up, it's going from the aphotic zone to the photic zone. It's carrying with it all the byproducts of decay and decomposition. The whales that died sink to the bottom and rot. Okay, there's no trees down there. There's no big kelp forest down there because there's no light. Okay, so as it moves across the sediment, it picks up nutrients, it pulls with it sediment itself, particulates. It hits that ramp, it shoots up, it's now in the photic zone, and it's like partay. You've got water, you've got light now for all these nutrients. You get these balloons. You get these big balloons of primary production. The upwelling itself is just this physical movement of water at depth to water into the higher up in the water column. Now, that's the phenomena. The significance of the phenomena is that it brings nutrients to the surface into the photic zone. And then they get sucked up by the primary producers. The nutrients get sucked up by the primary producers. That is the significance of an upwelling. So there's a difference that you can partition in your head. What is it? Why am I learning about it? Why you're learning about it is important because it's going to help define where primary production occurs in the oceans. Okay? And without the upwelling, all of those nutrients would sit at the bottom of the ocean into what is called a sink. All right? There would never be anything to bring them back into circulation for use. So it'd be basically like taking food, putting it into a drawer, never opening the drawer again. You've taken the food out of use and no one can use it. You open the drawer, you take it back up, everybody's like, eh. Actually, making this food in drawer, all my kids' Halloween candy I stole. I don't need all that shit. Dad needs it. Miss Hendrickson, how does that work for an explanation? Okay. It helps when you use all the hand motions, sounds. It does. It sounds weird, but it does. So that's what you got to practice at home with your pet rabbit and whatever it is. Put your pet rabbit down and say, all right, let me tell you about upwelling's little pet rabbit. As long as you scratch her, I don't think she cares. What other questions are floating out there? Water, upwelling, floating. Okay. I'd say it's been a long semester. Yes. Keep at it. The light is now visible at the end of the tunnel. I think I told my other class, I can't remember who I say what anymore, but you know, particularly this is your first year in university, maybe this is your first semester. You can't stop working, number one. And number two, particularly in the fall semester, students get to Thanksgiving and think, I'm done, baby. And it's like, nope. It's like it's painful. Actually, I would outlaw Thanksgiving in the fall semester, or I would have the semester end just before Thanksgiving, because students have a tendency to get to American Thanksgiving and think, I'm done. But you still have 2 weeks, and I'm willing to bet in most of your classes you've got some major project, essay, assignment due in those last 2 weeks, and then you have finals. Okay? And when I was an undergrad, I'm sure you like these stories, right? God damn, kids, I walked to school uphill to get to school, and then I had to walk uphill to get home. You don't know what I'm talking about. So, you can't psychologically check out at American Thanksgiving. This is all I'm warning you. This is year one, perhaps this is semester one. Do not check out at American Thanksgiving, because you still have probably a significant portion of your course grade to go. There are these big assignments that are going to be due in the final exams, depending on how they operate. Every course is going to be different, so I can't speak for everything. When I was an undergrad sitting in your seat, my final exams were 50% of my final grade. So you could work your ass off all year, but if you didn't keep the pedal down, you walked into the final exam, and that's 50% of your final grade. So, if there's any encouragement I can give you is keep working. You will get there. Don't check out at Thanksgiving. Okay? That was a new phenomenon to me. I think I went into my final grades with about 3 A's, and I walked out with 1 that semester because I stopped working. I was used to high school mentality of, well, I'm 3 weeks within the end of the semester. I stopped doing work in high school. I used to take zeros in the last 3 weeks of high school because I didn't want to work anymore. I earned a pass. I knew I was going to pass. We're done. And you can't do that in university. I learned the hard way. You don't have to make the same mistake. All right. Other questions? You guys are doing well to stay in here this long. Keep asking questions. So keep your, we're approaching 2:30, whatever it is, and technically it ends. I'll hang on for another 10 minutes or so. Keep your eye open for a message from Professor Cottrell. With respect to Thursday, I suspect she'll do something because she knows that you got a test on Tuesday. So she'll be available to answer questions. I actually teach another class, so I'm unavailable that day at that time. But she knows this stuff too. And of course, you can find me in email or discussion board. Okay? So just a reminder, next Tuesday, week from today, somewhere in the time block of 1 to 2:30, it will not be an hour-and-a-half test. You should expect similar format from what you've seen before. There are similar testing conditions. And I've got it on my list here to edit that learning objective statement on number 9. And I will use, who brought it to my attention, Cassidy's comment of Liebig's law of the minimum. Okay. Anything else for me? Okay, Addison, take care. Keep working. Don't forget your last assignment, right? You only have one assignment. I'd rather you spend the time preparing and thinking for the test. So one very, supposed to be 4 fun assignment. Probably do it in 20 minutes. You're done. Yes, you're welcome, Peyton. Jessica, take care. I'm going to sign off here.